And this section is on inequalities. So we're going to be looking at the different types of equations that we looked at in Unit 3. Those are why am I like blanking right now? So we're going to start here with our parabola. Thank you. That's the word that I wanted to get to. Our quadratic. And we're going to try to say, okay, well, based on, you know, it would be helpful if I put it up. So then we're going to say, okay, we're not worried about an equation because we could look at this and say, okay, well, y is 0 when x is -1 and x is negative 1 and -3. So those would be the solutions if I tried to solve this. We could even turn that back into an equation. But here we're more concerned about this inequality. So keep in mind that function notation is the same as y. So this is y is less than 0. So I want to know for what values is y less than or equal to 0. So keep in mind that here is my y-axis. Y is 0 every value on the x-axis. So for every y value on the x-axis, you get 0. Every y value on the x-axis is 0. So I want to know, where is y less than 0? Well, that would be everywhere below the x-axis. And so this inequality specifically, or this parabola specifically, excuse me, is less than 0 in between -3 and -1. See how this whole piece of it, should have gotten a pen. See how that whole piece of it has negative y values? So since every piece of this section of the parabola would have a negative y value, that's what they want to know right here. Since it's less than or equal to, we're going to include the intercepts. So this would be -3 to -1. Now, had this strictly been a less than, I would have used parentheses. Because remember, we said this is a symbol of inclusion. These are symbols of inclusion. So if this had been a symbol of exclusion, meaning strictly less than 0, then I would have used my exclusion symbols, which are parentheses. If they would have asked me for what values is y greater than 0, then I would have wanted everything above the x-axis. And so then I would have said, well, that's up here from -infinity until -3. And then y is positive again, starting at -1 until positive infinity. So if it would have said where is y greater than 0, then I would have picked all of these values up here. Now, keep in mind this says where is y greater than 0, but they still want your x values. So they're asking for what x values is y greater than 0. And so these are the x values where y is greater than 0. These are the x values where y is less than or equal to 0. Okay? And again, this question didn't ask me this. I just wanted to review it with you while we were looking at it. Okay? So if you're given an equation that is not as easy to see visually, then you're going to set yourself up a number line. And we would say, we would solve this the same way as we would solve it if it were an equation. And we would say, okay, where does x minus 1 equals 0? That's at 1. Where does x minus 8? Where does x minus 8 equal 0? That's at 8. Okay? We're going to plot those points on this number line they gave me. So we're going to put a dot on 1 and a dot on 8. And I'm putting closed dots because this had the or equal to. If this had not had the or equal to, I would have put open dots. Okay? And then what I'm going to do, now see how I've split this into 3 sections? I'm going to test a number in each section and see what happens. So if I want to look at the numbers to the left of 1, the easiest one I think to plug in would be 0. So I'm going to test 0. And what happens when I plug in 0? So when I plug in 0, I get 0 minus 1 and 0 minus 8. So that's going to be -1 times -8, which is 8. Is 8 less than 0? No. So then this is false. And I'm not going to shade in that area because my test number in there was not true. Now I'm going to pick a value in between 1 and 8. Let's do 2. And I'm going to test that. 2 minus 1, 2 minus 8. 2 minus 1 is 1. 2 minus 8 is -6. 1 times -6 is -6. This is true. So when I plugged in 2, I got an answer that was true. So then that means that this whole section, for that whole section that you got that true value, you're going to shade that in, that section of the line in. Now we also need to check on the right of 8. So let's pick 10. And again, you can pick any number that you want. These are just my choices. If you would have put -1, -2, -3, or even -1 million here, that would have been fine. You could have done 3, 4, 5. You could have done pi. You could have done, I don't know, any crazy thing you wanted as long as it was in between 1 and 8. And then here you can do any number greater than 8. So if you feel like doing 10,000, then go crazy. These are just the numbers that I picked because, I don't know, I have no good reason, honestly. So 10 minus 1 times 10 minus 8, that's going to be 9 times 2, which is 18. Is it true that 18 is less than 0? No. So this is false. So then I'm not going to shade in that section of the line. And so then this section that gave me my true value, that's my solution. So as a compound inequality, you would say that x is in between -1 or +1, excuse me, and 8. When I was testing these, I got that part wrong like 3 times in a row because I didn't see that it said write it as an inequality, and I just kept on putting interval notation, and I was getting really mad at myself.
I did the exact same thing and was getting really upset at the homework, and then when I realized, I was like, oh, that's what I'm supposed to do.
Yeah, because I will, like, some of these are new to me. You know, I've mentioned to you guys that I haven't taught this, like this class in this way. Like, I had my own way of doing it before the world went insane. But I don't think that way would have translated to this format very well. So, I will go through, and the questions that don't look familiar to me, that are not the same as the ones that I used to use, which like 90% of them are, I'm like, oh, well, let me try it. And I'm telling you, this one made me mad. Like, why are you asking me for an inequality when everywhere else you ask me for interval notation? Stupid. Anyway, look, please don't make the same mistake that both Alyssa and I made. And make sure that you're reading and that you're checking to see what it's asking you for. Okay. So, for this one, we're going to do essentially the exact same thing that we just did. And we're going to say, okay, w plus 6 equals 0. So w equals -6. W minus 7 equals 0. So w equals 7. W minus 6 equals 0. So w equals 6. And now we're going to set up our own number line. And our number line would then be -6, 7, and 6. No. Cool. 6 and 7. Aha. And so since this is strictly greater than, we would do open circles on all of these. And I know it's not asking us for the graph, but for me, I like to have the graph complete and correct. That way I can translate that into interval notation. And then we're just going to test, well, here we're going to have to test 4 values, 1, 2, 3, 4. Okay, so I'm doing this test in my calculator because why would I do it by hand? So let's test a value to the left of -6. I'll test -10. So 4 times -10 plus 6 squared times -10 minus 7 times.
Would the 4 be in there as well, or is it just everything in the parentheses?
No, I would use the 4 also.
Okay, just
Honestly,
making sure.
it's not gonna, the 4 is not really gonna make a difference because like we're really looking more for signs here than anything else, but you should include it.
Okay, thank you.
So we wanted a positive result. We wanted something greater than 0. Did we get something greater than 0? We sure did. So then that means that this section of the graph is good. Okay, let's test a number in between -6 and 6. I think 0. If I can use 0, I use 0 because I like it. So 0 plus 6 squared. 0 minus 7. 0 minus 6. Okay. I'm sort of surprised that one worked. Did I mess something up? Negative, negative. It's going to become positive. That's going to be positive. Huh. Okay. Cool. So a number between 6 and 7, we should do like 6.5. And again, we're still looking for something greater than 0. So this time we did not get a number greater than 0. So we're not going to shade in that section of the graph. 10 plus 6 minus 7, negative 10 minus 6. Okay. All right. And then last but not least, a number greater than 7. So I'm going to do positive 10. And I just kept on pressing second enter until I pulled this one up. And I'm just going to delete out my negatives. Yep, that works. And so I feel like this looks weird, but remember that the squared, remember from earlier in our polynomials unit, that the squared means a bounce. So that means that right here, the graph is going to touch and then go back up. So that's why your y values are positive on both the left side and the right side of this. Okay. So then in interval notation, we would say all of the numbers to the left of -6, but not -6, because at -6, your value would be 0, and they only want greater than 0. Everything in between -6 and +6, and everything greater than 7. Okay, now for this one, I'm going to solve this like it's a regular quadratic. So I'm going to put everything on one side. I move over the 11v and the 30 because I like for my leading coefficient to be positive. It makes factoring easier. And so now I ask myself, are there two numbers that multiply to 30 and add to 11? There are. 5 and 6. So then we have v plus 5, v plus 6, so negative 5 and negative 6. And then let's set up our... Now, one of the things that I like to do that, you know, I'm not sure, I honestly don't remember because I haven't watched Andy's videos in a while, but I prefer to go back to the original equation as opposed to any equation that I've modified, because that way, if I made a mistake and something weird happens on my graph, then I'm like, whoa, something weird happened on my graph. Let me go back and double check and see if I made a mistake. I put these backwards. Hello. Okay, so I need a number to the right of, or to the left, excuse me, of negative 6. So how about negative 10? So negative 10 squared is positive 100. And then negative 11 times negative 10 minus 30 is 80. So what I wind up here, when I plug in negative 10, I wind up with 100 is greater than or equal to 80. Ooh, you can't see. Is that true? Yes. And then we'd want to close that because it had the or equal to. Okay. Now I need a number in between negative 6 and negative 5. So how about negative 5.5? So a negative 5.5 squared is going to be 30.25. And then negative 11 times negative 5.5 minus 30. So these were close. I have 30.25 is greater than or equal to 30.5. Well, that's not true. So I'm not going to shade in that section. And then we need a number to the right of negative 5. So I'm going to do 0, because again, if I can do 0, I do 0. So 0 squared would be 0. And then negative 11 times 0 is 0. Minus 30 is negative 30. Is it true that 0 is greater than negative 30? Yes. So I'm going to shade in this side. So then in interval notation, I would say negative infinity to negative 6, negative 5 to infinity. And then for the rationals, it's pretty much the same thing, but instead of just looking for your zeros, you're also going to look for your asymptotes. So for example, here, there's not a whole lot I can do with the 4 on this side. So I'm going to move the 4 over, and I'm going to wind up with t plus 8 over t plus 7 minus 4 is less than 0. But in order to be able to combine these two fractions, they have to have the same denominator. So I'm going to multiply that 4 by t plus 7 over t plus 7. Ooh, I don't need a parenthesis right there. Because now they both have a t plus 7 in the denominator. And so then that's going to become t plus 8 over t plus 7 minus, I'm going to distribute this 4 on the top, 4t minus 28. Is still less than 0. So when I combine, a t minus 4t is negative 3t, and 8 minus a negative 28 is the same as 8 plus 28, so that's going to be 36 over t plus 7. So to find my vertical asymptote, I set my denominator equal to 0 and solve. So that's t plus 7 equals 0, so t equals -7. And then my intercept, I set the numerator equal to 0 and solve. -36. So then t equals 12. When I divide -36 divided by -3. And so then those are the values that I use for my number line. So again, we need to worry about both numerator and denominator here. So I have a -7 and a +12. I'm going to plug in a value to the left of -7. So that's going to be -10. You can tell that I like to use the same numbers over and over again, right? So I have, when I plug in -10, I wind up with -10 plus 8 over -10 plus 7. So that's 2/3. Is it true that 2/3 is less than 4? Yes. So this would get an open circle because again, it only had the less than, and I shade this way. Now let's check a number between -7 and 12. I'm going to do 0 because that would just be 8 over 7. And so 8 over 7, when I plug in 0, I get 8/7 is less than 4. That's true also. And then let's plug in a number greater than 12. So how about 20? 20 plus 8 over 20 plus 7, parentheses. Well, that works too. I'd be interested to see what the graph of this one looks like. Unless I made a mistake somewhere. -4. Nope, it's good. Let's see. Tx plus 8. X plus 7. Then a -4 on the outside. Weird. Maybe I did mess this up somewhere. -3t, 36. Let me look at this one. It's less than 4. Maybe it's less than 0. Oh yeah, never mind. Okay. So for this last one, we're going to do the same thing, only we're going to have to factor top and bottom. So are there two numbers that multiply to a +21 and add to a -10? Yes, that would be -3 and a -7. Are there two numbers that multiply to 64 and add to 16? Yes, that would be 8 and 8. So then my vertical asymptotes are at c plus 8 equals 0, which is -8. And my intercepts are at c minus 3 equals 0, which is c equals 3, and c minus 7 equals 0, which is c equals 7. So I have a -8, I have 3, I have 7. So a number to the left of -8, we'll do -10 again. Leave another parenthesis. -10 squared minus 10 times -10 plus 21 over -10 squared plus 16 times -10 plus 64. I just want to make sure I didn't miss a negative in the beginning. Oh, 10 times negative minus 10 times. Okay. Is that less than 0? No. Okay. So I'm not going to shade in that part. In between -8 and 3, I'm going to use 0 because I'm going to cover this up. That would become 0. This would become 0. This would become 0. This would become 0. And I'm left with 21 over 64. Is that less than 0? No. Okay. So let's try 3. A number in between 3 and 7. Let's do 5. 5 squared minus 10 times 5 plus 21 over 5 squared 16 times 5 plus 64. That is less than 0. So I am going to shade in that part of the graph. And then a number greater than 7, let's do 10. 10 squared minus 10 times 10 plus 21 over 10 squared 16 times 10 64. Okay, so that's it. That's the only section of this graph greater than 0. So from 3 to 7. I don't think the inequalities are that bad because it's just the same process over and over again, no matter what type of equation you're looking at, just with the testing, making a number line and testing. And if your test checks out, then you shade in. If your test doesn't check out, then you don't shade in. But you do have a quiz due tomorrow also.